Hello, in this video we're going to study an integration technique that involves partial fraction decomposition. This is a technique where you essentially unfactor a denominator that has been combined together. A theme that you'll see in integration is if you can take a big complicated integral and break it into two or three less complicated integrals, that's almost always a good plan, and that's what we're doing with this technique. I'm going to start out with just a very simple example. We're going to do the integral of x minus 12 over x squared minus 4x. So typically, a great way to start a question like this is to ask yourself, is the top of this fraction the derivative of the bottom? Because if it is, you have a natural log integral. And in this case, it's not. So what I want you to do is take what's in the integrand and think about the bottom and say, okay, x squared minus 4x, that is the same as x and x minus 4 if only you had the right numerators. So if you just think about it, if you were in algebra 2 and you had this and you had to add these together, that would be the denominator you would get. That's a common denominator. So what partial fraction decomposition is a way for you to start with this and go backwards and break it into this and this. If you have a denominator that's just an x or just an x minus 4, something that's a first degree, it'll be much easier to identify a natural log style of antiderivative that you could use. So for now, we've got x minus 12 up top. And what I'm going to do is I'm going to just imagine we have an unknown number a and b right there. So with those unknown numbers a and b, I'm going to just go ahead and use my algebra 2 skills and add these together with a common denominator. And what you're going to do is you're going to have to find a common denominator. It's going to be x times x minus 4. So here you'll multiply by x minus 4 on the bottom and on the top. And then over here, you'll multiply by x on the bottom and on the top. And I can't really see that very well. I'm just going to go ahead and write it in blue. So multiply by x minus 4 on bottom and top, and then x on top and bottom there. And so what you can end up with will be x minus 12 over x squared minus 4x. The bottom is going to be x times x minus 4. And on top, you'll just use the distributive property and get ax minus 4a plus bx. So we've got two fractions and they're equal to each other. If the bottoms are equal to each other, then the tops also must be equal to each other. So I'm just going to go ahead and say, therefore, x minus 12 equals ax minus 4a plus bx. So we want to solve for a and b. And typically, if you want to solve for two variables, you want two equations. And we don't have that. We just have one equation. So going back to your Algebra 1 skills when you learned how to, set up a system of equations with two variables and two unknowns and solve, I want to kind of change that theme, not two equations, but two facts. So to solve for two unknowns, you need two facts. Three unknowns, you need three facts. And the facts I have here, one is just the equation itself. And the other is the fact that these can be written in the same format. So I'm going to just write this down. We have 1x minus 12. And by format, I see a and x and bx. That's going to be a plus bx and minus 4a. By the same format, what I mean is a number times x and then plus or minus a constant. So these are written in the same format. And so what you can do is you can say, well, if the coefficients of x are equal and these little linear equations are equal, then the constants also have to be equal. So we're going to say a plus b is going to equal 1, and therefore minus 4a is going to equal minus 12. And then you can see a equals 3 and b is minus 2. So now what you can do is you can go back and you can say, I really wanted to integrate, what was a? A was 3 over x. And then I wanted to integrate negative 2 over x minus 4. And now you've broken this into two integrals that are added that mean the same as this, but they're actually doable. If you took the 3 out, this would be 3 natural log x. Take the minus 2 out, 2 natural log x minus 4 plus c. And that is an example of partial fraction decomposition. Just walk through this again real quick. We took something that we didn't know how to deal with. We broke it into two pieces. The two pieces we did know how to deal with. To break it into those two pieces, we factored the bottom, wrote them as separate terms, and then put an unknown a and b up top. And then we just kind of went through the algebra 2 style process where we add these together with the common denominator, and we arrange these in the same format where we have x plus or minus number, x plus or minus number, and then we just solve for a and b by equating the coefficients of x and equating the constants. Let's try another example. Start with that. Before we do anything, we need to obviously factor the bottom. So this could be 2x and 1x, and I guess minus 3 and plus 1 should do the trick for us. So this 7 over 2x squared minus 5x minus 3 is going to be equal to a over 2x plus 1 plus b over x minus 3. And we will go ahead and combine those together by adding them together as common denominators. Here I lack an x minus 3, so I'll multiply by x minus 3 on bottom and on top. And then here I'll multiply by 2x plus 1 on bottom and on top. And so now the bottoms are going to be the same, 2x squared minus 5x minus 3, with 7 on top. 2x plus 1 times x minus 3 is the same. We have ax minus 3a plus 2bx plus b. And so the bottoms are the same, and that means that the tops are also the same. And I'm going to just take the liberty of adding 0x here because I know that we're going to have an x term also, and that just happens to be 0. That's fine. We're going to write down 0x plus 7. I've got ax and 2bx. We're going to do a plus 2bx, and then minus 3a plus b. And we'll have a plus 2b equals 0 because the coefficients of x are going to be the same. And then minus 3a plus b equals 7. And now we truly are back to algebra 1. I'm going to choose to just multiply this top equation by 3. So we get 3a plus 6b equals 0, and minus 3a plus b equals 7. So 7b is 7, and b is 1. If b is 1 here, that's 6, and then a would have to be minus 2. So we'll go back upstairs and up here, and I'm going to have this was negative 2 over 2x plus 1. And then we had b was 1 over x minus 3. And now if you think about, I'm just going to kind of block this off for now. If you think about what's the derivative of 2x plus 1? Well, it's 2. And we actually conveniently have a 2. It doesn't have to work out like that, but it just did here. I'll take the negative out, and this will be negative natural log of 2x plus 1. And then this will be plus natural log x minus 3 plus c. So look at that as my answer to that integral. And before we continue, I want to make some comments about these answers. This one and the previous one. I'm just going to write that down here again and show you what you might find if you were to look at an answer key. So imagine that. If you think about your rules of logarithms back in Algebra 2, again, recall natural log of a minus natural log of b is natural log of a over b. And here, what you could do is you could rewrite this in a different order where you have natural log of x minus 3 minus natural log of 2x plus 1. And that would oftentimes be written as natural log x minus 3 over 2x plus 1, and then plus c. So that's an option that you may have thrown at you, especially if you're looking at a multiple choice answer. You may have done correctly, gotten this, and it was simplified with log properties, and maybe you missed that. Just like the other one could have been written in the same way. We got a minus here. Let me just write that one again up at the top here and just remind you how your log properties could have been used. In this case, to natural log x minus 4. That was my answer just a minute ago. In this case, the 3 can come up as an exponent of the x. The 2 could come up as an exponent of x minus 4, and the minus could make it a fraction. So this could have been written as x cubed, x minus 4 squared on bottom plus c. So that's another alternate version of the answer using log properties. If you don't remember log properties, they come back over and over and over. Make sure you know the 3 log properties before we continue much farther in the course. Let's try another question. Okay, let's try this. So obviously the bottom factor is x plus 1 times x minus 1. The top is a cube. And so we have a major roadblock here. Partial fraction decomposition only works if the power on the top is lower than the power on bottom. It won't work otherwise. So if you see something like this, it doesn't mean you can't do it. It just means you need to work on it first. You need to work on simplifying this first. And we're going to do that with some more Algebra 2, dividing polynomials with long division. So we're going to need to re-express this 2x cubed divided by x squared minus 1. So let's just do that down below here. 2x cubed, x squared minus 1, I'm going to say plus 0x squared plus 0x plus 0, just to kind of fill my spaces. X squared times what is 2x cubed? Well, 2x. 2x times x is 2x cubed. 2x times minus 1 is minus 2x. Subtract, just like we always do. 0, 0, minus 2x plus 0. Can x squared go into 2x? No, it cannot. So we're going to have a remainder of this, minus 2x, and then x squared minus 1. So this is equivalent to that. So I could rewrite this as the integral of 2x plus the integral of minus 2x over x squared minus 1. And now, before you get too eager to do partial fraction decomposition, you might notice that you actually don't need to, because this has a nice integral of x squared. Integral of 2x is x squared. And this one is, if you take the negative out, what's the derivative of x squared minus 1? Well, it's 2x. This is minus natural log x squared minus 1 plus c. So that is kind of a trick question where you think you're going to have to do partial fractions, and then you actually don't have to do partial fractions. Let's do another one of kind of the same cut, the same type of problem. Okay, once again, we've got a very factorable question. On the bottom, at least, x squared minus x, so x can factor out. The powers are the same here. So I just told you want the degree to be the larger on bottom than top. You don't want them to be the same. So again, we're going to have to jump into division, long division, before we can do much else here. So we'll divide the top by the bottom. First question, x squared times what makes x squared? That's 1. 1 times x squared is x squared. 1 times minus x is minus x. These cancel out. Minus and minus makes a plus. That's 2x minus 1. Does x squared go into 2x? It does not. So you're going to have plus 2x minus 1 over x squared minus x. And this is another pretty contrived type of question. It's a good textbook question because it's set up to work out nicely. That's not something you can always count on. 2x minus 1 over x squared minus x. What's the antiderivative of 1 dx? Well, it's x. Notice what's the derivative of x squared minus x? It's 2x minus 1. And oh, surprise, that's what's on top. So this is natural log of x squared minus x plus c. I think you're going to find, in reality, they don't always work out really nice like that, and you might have to go and you're likely to have to do a partial fraction decomposition just with this part, and then integrate that separately. But for now, it works out, pretty nicely. Okay. Let's look at a repeated linear factor. So this works a little differently. 5x over x squared plus 6x plus 9. So obviously, x squared plus 6x plus 9 is the same as x plus 3 squared, and that is a repeated linear factor. So the way that you deal with a repeated linear factor is you start out like normal. I'll just do x plus 3 squared here. But then you do x plus 3 squared, and then you do an x plus 3 to the first. So whatever the repeated factor's highest degree is, if this was a 4 power, you'd have an x plus 3 to the fourth, then 1 to the 3, then 1 to the 2, then 1 to the 1 with a, b, c, and d. Here we just have a repeated factor of 2. And so we're going to have x plus 3 to the 2, x plus 3 to the 1. It's not as intuitive why you're doing this at this point, but for now, just take my word for it. Hopefully it'll be more clear in a little bit. So now to add these together, a is just, it's there. It really doesn't need anything. If I want a common denominator, obviously it'll be x plus 3 squared. And this has already got x plus 3 squared, so the a just kind of chills there. This is going to be times x plus 3. And so we're going to have 5x over x plus 3 squared. Then we'll have x plus 3 squared with an a, and then plus bx plus 3b. And I'm going to say 5x plus 0 while we're at it. Since there's no constant there, I'll just put a placeholder of 0. And we can now say the bottoms are the same, and thus the tops are the same. 5x plus 0 equals bx plus a but plus 3b. So these go together. B equals 5, and then 0 equals a plus 3b. And you're going to have b as 5, so that's 15, and then a is going to be negative 13. So we're going to have currently negative 13 over x plus 3 squared. And then you're going to have 5 over x plus 3, like that. So that's my new iteration of this integral. You may be thinking, well, I don't. That doesn't seem like it helped a whole lot, and it actually did. And so the whole, when you have an x on top and you have this on bottom, you're limited in the modes of attack you can use. Once you get the x off the top and we just have the minus 13 up there and the 5 up here, there's more tools. And so for this guy, I'm going to use u substitution here in a moment. And for this one, this is going to be a log integral. And I think I'm going to actually rewrite it down below so you can see it a little bit more clearly. But you always want to break this down into two pieces if you can. So for I think I actually might use a new piece of paper just to really make this clear. We have the integral of minus 13 over x plus 3 squared, and then 5 over x plus 3. That's where I was. I'm going to just go ahead and make my u x plus 3 for this first integral. Du equals dx. So this would be minus 13, and then you would have u to the minus 2 du. The power goes up by 1 and divide by that new power, so we have u to the minus 1 over minus 1. And that would be positive 13 over u, which is positive 13 over x plus 3. So this is the integral of this first portion, positive 13 over x plus 3. And then this guy would just be 5 natural log x plus 3 and then plus c. So my total integral will be 13 for x plus 3 plus 5 natural log x plus 3. If you wanted to get fancy on me, you could say x plus 3 to the 5th and bring your power up with the exponent rule for logarithms. So anyway, again, that's just an example of a repeated linear factor and how you kind of treat that specially. Let's do let me find my problem here. Let's do one more with a case with where you have to use division first. So again, these match. So before we can really do much, we need to say 2t cubed is divided by t cubed minus t. I'll make this plus 0t squared plus 0t plus 0. T cubed times what makes 2t cubed? That's 2. 2 times t cubed is 2t cubed. 2 times minus t is minus 2t. and then you get 2t as a remainder because t cubed does not go into 2t. So you get t cubed minus t. So this problem is going to be a little bit different than all the other ones we've done. You're going to have the integral of 2. That one's no problem. But now you've got the integral of 2t over t cubed minus t. And it does fit into the mold of, yeah, I want a lower power on top than the bottom, but I have a cube here. So this is actually going to have 3 factors instead of just 2. So I'm going to just kind of mosey down the page here, and I want to spend part of our page breaking down at 2t over t cubed minus t. I'm going to write that. That factors into t times t plus 1 times t minus 1, by the way. We'll have A, B, C. So to start making this happen, the t needs to be multiplied by t plus 1 and t minus 1. I'm just going to collectively do that as t squared minus 1. And then this needs to be multiplied by a t and a t minus 1, which is really t squared minus t. And this guy needs to be multiplied by a t and a t plus 1, which collectively is a t squared plus t. So what you're going to have is you're going to have 2t over t cubed minus t. And then downstairs you'll have t cubed minus t as well. And you're going to have at squared minus a plus bt squared minus bt plus ct squared plus ct. What a mess. And you just have a 2t over here. But the tops are the same. I'm sorry, the bottoms are the same, so thus the tops also have to be the same. So we're going to say, I'm going to just kind of draw another little line here to stay organized. 0t squared plus 2t plus 0. We've got 2 squared terms, so we'll have a plus ct squared. And then we've got a t term, 2t terms, so we'll have plus c minus b t. And then we've got a, and we've got plus negative a. So it looks like 0 equals a plus c. And then we'll have negative a equals 0. And then 2 equals c minus b. And if c is 0, it looks like all a and c are 0, so b has to be negative 2. So what this tells me is that you really only need the middle term negative 2. And I want to just show you something kind of algebra-wise that would have maybe tipped you off to this in the ahead of time. So let me just show you a new piece of paper. I'm going to write out what we had a moment ago. And 2 dt. And then we've got 2t over t cubed minus t dt. That's what we had just a second ago. And then what I've just determined is that the a is 0, thus this, the a is 0, thus the c is 0, b is minus 2. So really what we would have here is 2 dt plus, by the way, the b was minus 2, and that was over the t plus 1. So we'd have plus minus 2 over t plus 1 dt. If you had looked at what we had up here and noticed that t isn't everything, you could have actually solved, you could have knocked a t out of everything first, and you would have had 2 over t squared minus 1. And then you could have done partial fractions on that, and it basically ended up here. a little faster. I'm not going to do that again. I wanted to just kind of leave the extra t in there so you could see that, if you do have a cube, you just have an A, B, and C, or if you have a higher power, you can have really as many letters as you need to have. So this guy would be ultimately 2t, and then minus 2 natural log of t plus 1, and then plus c. So anyway, that should wrap up partial fraction decomposition.